Metals and nonmetals. Introduction. Elements are classified as metals and nonmetals. Metals are generally hard solids and have a luster. Most of the metals are malleable, ductile, and some of them are good conductors of heat. Calcium, aluminium, zinc, copper, mercury are examples of metals. Metals are helpful to us in many ways. We use them in the construction of houses, automobiles, electrical appliances, and also plays a key role in the transmission of electricity. Malleability. Take a small iron nail, a coal piece, a piece of thick aluminium wire, and a pencil lead. Beat the iron nail with a hammer. Try to hit hard. Hit hard the aluminium wire also. Then, repeat the same kind of treatment on the coal piece and pencil lead. The shape of the iron nail and the aluminium wire changed on beating. If they were beaten harder, these could be changed into sheets. You might be familiar with silver foil used for decorating sweets. You must also be familiar with the aluminium foil used for wrapping food. The property of metals by which they can be beaten into thin sheets is called malleability. The property of metal by which it can be drawn into wires is called ductility. Material properties. Some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of heat and electricity. The materials which generally possess these properties are called metals. The examples of metals are iron, copper, aluminium, calcium, magnesium, etc. In contrast, materials like coal and sulfur are soft and dull in appearance. They break down into a powdery mass on tapping with a hammer. They are not sonorous and are poor conductors of heat and electricity. These materials are called nonmetals. The examples of nonmetals are sulfur, carbon, oxygen, phosphorus, etc. Chemical properties. Collect a spoonful of rust and dissolve it in a very little amount of water. You will find that the rust remains suspended in water. Shake the suspension well. Test the solution with red and blue litmus papers. It turns red litmus blue, which is basic in nature. Chemical properties of metals. When a copper vessel is exposed to moist air for long, it acquires a dull green coating. The green material is a mixture of copper hydroxide, CuOH2, and copper carbonate, CuCO3. The following is the reaction. 2Cu plus H2O plus CO2 plus O2 gives CuOH the whole 2 plus CuCO3. Oxides of nonmetals. Take a small amount of powdered sulfur in a deflagrating spoon and heat it. If deflagrating spoon is not available, you may take a metallic cap of any bottle and wrap a metallic wire around it and give it the shape as shown in figure. As soon as sulfur starts burning, introduce the spoon into a gas jar or glass tumbler. Cover the tumbler with a lid to ensure that the gas produced does not escape. Remove the spoon after some time. Add a small quantity of water into the tumbler and quickly replace the lid. Shake the tumbler well. Check the solution with red and blue litmus papers, as shown in figure. The name of the product formed in the reaction of sulfur and oxygen is sulfur dioxide gas. When sulfur dioxide is dissolved in water, sulfurous acid is formed. The reaction can be given as follows. Sulfur dioxide SO2 plus water H2O gives sulfurous acid H2SO3. The sulfurous acid turns blue litmus paper red. Generally, oxides of nonmetals are acidic in nature. Reaction with water. Let us see how metals and nonmetals react with water. Take a 250 ml beaker or a glass tumbler. Fill half of it with water. Now, carefully cut a small piece of sodium metal. Dry it using filter paper and wrap it in a small piece of cotton. Put the sodium piece wrapped in cotton into the beaker. Observe carefully. During observation, keep away from the beaker. When reaction stops, touch the beaker. Test the solution with red and blue litmus papers. It is observed that sodium reacts vigorously with water. Some other metals do not do so. Generally, non-metals do not react with water, though they may be very reactive in air. Such non-metals are stored in water. For example, phosphorus is a very reactive non-metal. It catches fire if exposed to air. To prevent the contact of phosphorus with atmospheric oxygen, it is stored in water. Prepare a fresh solution of sodium hydroxide in a test tube by dissolving 3 pellets of it in 5 ml of water. Drop a piece of aluminium foil into it. Bring a burning matchstick near the mouth of the test tube. Observe carefully. A pop sound is produced. The pop sound indicates the presence of hydrogen gas. Metals react with sodium hydroxide to produce hydrogen gas. Displacement reactions. Take 500 ml beakers and label them A, B, C, D, and E. Take about 50 ml of water in each beaker. Dissolve in each beaker a teaspoonful of each substance as indicated in figure. Keep the beakers undisturbed for some time. Record your observations in your notebook. In beaker A, zinc, Zn, replaces copper, Cu, from copper sulfate, CuSO4. That is why the blue color of copper sulfate disappears and a powdery red mass of copper is deposited at the bottom of the beaker. The reaction can be represented as follows. Copper sulfate, CuSO4 plus zinc, Zn, blue, gives zinc sulfate, ZnSO4 plus copper, Cu. The first one is colorless, the second one is red. You can write down the reaction taking place in beaker B in a similar manner. There could have been displacement of zinc by copper in beaker C and by iron in beaker E. Similarly, iron could be displaced by copper in beaker D. Since we do not see any change in beaker C, we can infer that copper is not able to replace zinc from zinc sulfate. Zinc is more reactive than copper and iron. A more reactive metal can replace a less reactive metal, but a less reactive metal cannot replace a more reactive metal. Uses. Non-metal is essential for our life, which all living beings inhale during breathing. Non-metals used in fertilizers to enhance the growth of plants. Non-metal used in water purification process. Non-metal used in the purple-colored solution which is applied on wounds as an antiseptic. Non-metals are used in crackers.